All right, welcome to the Explainer. Today we are tackling what is, honestly, the biggest hidden problem in modern engineering right now, evaluating AI at scale. Look, when you're building with large language models, getting the system to just generate a response, that's actually the easy part. But knowing if that response is consistently good across thousands of user interactions, well, that is where the real nightmare begins. So, we're focusing on chapter 35 of our source text today, which breaks down exactly how to solve this by mastering LLMs as judges.
This quote from the author absolutely hits the nail on the head. It highlights a massive blind spot for so many development teams. Think about it. You make a tiny tweak to your prompt to improve formatting. And sure, the formatting gets better. But did the accuracy just drop? Did the tone become robotic? Without a reliable evaluation system, you are quite literally flying blind. You're just crossing your fingers and hoping your users don't catch the regressions before you do.
So, here's our game plan for today. We'll look at the core evaluation problem, define what LLM as judge actually is, walk through a concrete 5-step workflow, explore the pitfalls you definitely need to avoid, and then figure out how to choose the right model for the job. Let's get right into it. Starting with Section 1, the evaluation problem, and specifically why manual review completely breaks down the second you try to scale. To understand this, let's look at this real-world disaster from the source material. The author shares a story of a computer vision system built to identify car makes and colors. In the demo phase, just 50 images, it looked flawless. The bounding boxes were tight, the labels were perfect, high fives all around. But when they ran it on 50,000 images in production, the whole thing cracked. The model started mislabeling dark blue cars as black or silver cars as white, specifically when they were in the shadows or at dusk. You see, 50 demo images hid those subtle lighting failures. 50,000 exposed them. But here's the rub. You simply cannot hire enough humans to manually spot-check 50,000 outputs every single time you update your model. It's impossible. So, what's the fix? That brings us to Section 2. What is LLM as judge? Simply put, it's using one language model to score or critique another. Now, I know what you're thinking. That sounds completely circular, right? Using AI to grade AI. The author admits to being super skeptical about this at first, too. But the reality is, once you set this up correctly, it is the absolute definitive solution to this bottleneck. You're basically taking the tedious, high-volume grading work that humans no longer have the capacity to do and handing it over to a model. All right, moving on to Section 3, the 5-step workflow. This is how we actually build this pipeline and make it work in production. Here are the steps. Define your criteria, write a detailed rubric, calibrate with human labels, run it at scale, and choose the right judge. Let's break these down to see how you build this from scratch. Step 1. You have to explicitly define what good actually means. You cannot just ask an AI, hey, rate this output from 1 to 10. The AI has no idea what you mean by a 7 versus an 8. The scores will be totally random. Instead, you need to isolate specific criteria. Why? Because an AI's answer can be 100% accurate but also completely rude, or really complete but totally unhelpful. By separating evaluation into axes like accuracy, completeness, and robustness, you know exactly where your model is dropping the ball. Step 2. You need a crazy detailed scoring guide. A strict rubric gives the judge concrete boundaries. For example, look at this. A score of 4 means mostly accurate with one minor imprecision, while a 2 means multiple factual errors or one significant error. You are telling the model exactly what the rules are. Also, notice how it provides reference documentation as a source of truth and demands a one-sentence justification. That part is huge. It forces the model to actually reason out loud rather than just blindly guessing a number. Then we hit step 3, calibration. Look, before you just hand the keys over to the AI, you have to calibrate it against humans. The author suggests manually grading about 50 to 100 examples yourself. You want the AI to have at least a 70% exact match with your human scores and like 90% within 1 point. A lot of times, you're going to find out the AI is a bit of a pushover. It'll hand out 4s and 5s when a human would give a 3. If that happens, you just go back and make your rubric much more explicit about what a bad answer looks like. Step 4 is where the magic happens. You run this whole pipeline at scale. Once your rubric is calibrated, it all runs automatically. Tools out there like Langfuse or TeepEval allow you to trigger this evaluation every single time a prompt or a model is updated. The pipeline aggregates the scores, compares them to your baseline, and flags any failures. So instead of a human randomly reviewing 50 outputs and hoping for the best, you only manually review the exact instances where the automated score suddenly tanked by 2 points. It's a total game changer.
But hey, this system isn't completely foolproof. So let's look at Section 4, pitfalls and blind spots.
You have to actively defend against these weird technical biases. Take positional bias, for instance. If you ask an AI to compare option A and option B, a lot of models will just pick whichever one you showed them first. The fix? You run the test twice with the orders swapped. Then there's verbosity bias. This is where the judge thinks a super long, rambling answer is automatically a thorough, high-quality one. You literally have to tell the rubric to reward concise answers. And what about hallucinated justifications? Easy. You force the AI to explicitly quote the text it's judging so it can't just fabricate a reason for giving a good score.
Which brings us to Section 5, choosing the right judge to avoid bias. To avoid what is called self-preference bias, which is basically where a model loves its own work and rates it way too highly, you must never let your production model grade itself. Never. You should always use a stronger, distinct frontier model to judge the outputs of your cheaper day-to-day model. Now, if cost is an issue, you can use the expensive model just for your calibration set and a reliable, cheaper one for daily checks. Just make sure they aren't the exact same model grading its own homework.
Let's wrap all these technical details together into Section 6, the core insight here.
By adopting this 5-step workflow, LLM's judge takes evaluation from an impossible, manual nightmare and turns it into a scalable, automated machine. You stop flying blind. You finally gain the ability to catch regressions instantly, no matter the scale. Because, like we said at the top, building the AI feature is just step 1. This pipeline, this is how you ensure it actually works in the real world.
I want to leave you with a provocative question to ask your team tomorrow morning. Think about your current setup right now. If your AI subtly degraded after a minor update today, would your system even notice? Or would you only find out when the angry customer emails start rolling in? Building the AI is half the work. Knowing when it's wrong is the other half. Thanks for hanging out with me for this explainer, and I'll catch you in the next one.